Hello everybody. Today we're going to be talking a little bit more about vectors, which are quantities that have both a magnitude and a direction. The magnitude, remember, is just the size, but the direction is whatever direction this thing is acting. There are a lot of different types of vector quantities. Things like displacement, velocity, those are all vector quantities because they have a magnitude and a direction. But today we're going to be talking about the question, how do you describe the direction? It turns out that direction is a little bit more difficult to describe than what you might think. So let's talk a little bit about three different ways that it happens. So let's start off, let's just put in something to refer to, a big plus sign with vertical and horizontal axes on it, so we have something to refer to. The first way we can describe direction is by talking about what we call the relative direction. And the relative directions are just like when you look at this thing, it kind of looks like a plus sign. Well, the top is up, the bottom is down, to the left is left, to the right is right. Makes perfect sense. And so if we have this Jeep out here and it drives in this direction, we could say, well, it drove to the right. Or if we were giving a displacement vector, we might say it traveled so many meters to the right. And that's fine, except you run into an issue of what if somebody else was observing this from the other side of the Jeep? From that vantage point, they would be saying it traveled to the left. So when we use relative direction, the direction depends upon your point of view when you're describing it. So another way that we have come up with to describe direction, we say it uses the cardinal directions. And the cardinal directions, now when we write them out on paper, up is north, down is south, to the right side on the paper is east, and to the left side on the paper is west. And so if our Jeep moves like it did here, now we would say, well, it moved to the east. And an observer who is on the other side of the Jeep describing the motion, they would describe it the same way. They would also say, well, it traveled to the east. And to represent this vector on paper, we would just draw it as an arrow pointed in the direction of east. And this works really well as long as the motion or the displacement or whatever vector it is that we're describing is in one of the cardinal directions. If something travels straight north, we say, well, its heading was due north. Or if a force was acting to the west, we can say, well, that force was acting due west or straight west. But things get a little bit more complicated if the thing is acting in between. For example, what if our Jeep turns a little bit and it heads off in that direction? Now when we put it on paper, the vector ends up being in between north and east, like this. And so we might say, well, it traveled to the northeast. And that's true, but it's not really very accurate, because as you can see, our green vector is closer to the east direction than it is to the north direction. And not only that, we have this whole quadrant, we have this whole range of 90 degrees that could be considered northeast. So how do we get more precise? Well, there are three ways to do this. Now the first one I'm going to describe to you, I'm describing simply because it's one that you're liable to run into, but it's not a method that we use in this course. But because it is out there and because it's actually fairly common, I did want to describe what's going on with it. And this is what we would use when we're talking about like navigation. If you're in an airplane and you're talking to an air traffic controller and they tell you to take a heading of a particular direction, the standard way that they do it is they always consider north 0 degrees. And then if we rotate around in a clockwise direction, east would be in a direction of 90 degrees, due south would be 180, west would be 270, and so we can describe a particular direction by just giving a single angle. In this case, that Jeep, if we measure the angle between north and the green arrow, it's 60 degrees. So using this navigation standard, we would say, well, that Jeep headed off in a direction of 60 degrees. So the navigation standard for describing direction is you consider north 0, and then you just measure in a clockwise direction. But, as I say, this standard is not the one that we're going to be using in the course. I only mentioned it because you're liable to run into it in real life sometime. The method that we will use most often when we're describing a direction in this course is we compare to whatever is the convenient cardinal direction. In this case, it would be like this. Suppose we started and compared to north. So we put our blue arrow here, north, and if I want it to rotate now, so it's in the direction of our green arrow, which is the direction we're trying to describe, well, I've got to rotate it towards the east. And I've got to rotate it 60 degrees towards the east. So one way of describing that direction, we would say, well, that direction is 60 degrees east of north, which means we're on the east side of north and we're 60 degrees on the east side of north. But you might also be able to tell that, well, we could also compare to east. And if we compared to east and just rotate 30 degrees towards the north, now we're in that same direction. So besides saying 60 degrees east of north, we could just as legitimately have called this direction 30 degrees north of east. So comparing to whatever is the convenient cardinal direction, this would be described as either 60 degrees east of north or 30 degrees north of east. Then any directions in any of the other quadrants could be described the same way. It's going to be so many degrees away from whatever direction you're comparing to and in the direction of whatever direction you rotate toward. Now, the third way we do this is kind of like the navigation method that I mentioned before, but it also takes into math. In math, we use a unit circle quite a bit, which is based on the x-axis, the x and y axes. And if we work using the x-axis, well, due east then is considered 0. And when you number in the unit circle, this time it turns out that north is 90 degrees, west is 180 degrees, and south is 270. So with the unit circle, that first quadrant between 0 and 90 degrees is the upper right-hand quadrant. And so you number going around in a counterclockwise method. So in this case, if you use the x-axis as your 0 point, then you rotate counterclockwise from there by 30 degrees, and you would say, well, the direction that the Jeep drove was simply 30 degrees. If it headed off to the northwest somewhere, then the angle would be some number between 90 degrees and 180 degrees. If it was heading to the southwest somewhere, then the heading would be some angle measurement between 180 and 270, and so on. So, if we want to describe directions then, using the x-axis method, you'll get just a single degree measurement, and it's measured from east, and you rotate counterclockwise. So those are the methods that we will use when we're describing directions. In this course, you'll see either of these two that are up here on the screen now. And in real life, it is possible, and in fact likely, that sometime you'll run into that third method of describing directions as well. So I hope this makes sense, and I hope it helps you out as you work with vectors.